Alright, part 3 of the trig substitutions. We're finally going to look at the top one, the tangent. So we use the tangent if we have a sum variable squared and a constant in either direction, okay, because addition is commutative. It doesn't matter which way it is if there's a sum involving a squared variable. Alright, so this example, notice in the numerator we've got squared variable plus something. So we're going to use the tangent, and the way we use the tangent is, again, square root of 64 is 8 times the tangent of theta. Okay, so that means that dx is going to be equal to 8 secant squared of theta. Alright, and it also means that the tangent, if I divide both sides of this by 8, I get tangent of theta equals x over 8. Now remember, right triangle trig, tangent is opposite the angle, so opposite over adjacent. So the opposite side is x, the adjacent side is 8, opposite over adjacent. So that's why this is set up this way. And then the Pythagorean theorem says that I can find this by squaring these two and adding them together. So the square root of x squared plus. Now quickly glancing at our integrand, we need the square root of x squared plus 64 to be in the numerator. So we need this to be in the numerator. And then there's a constant, and there are 2 down in the bottom that we also need. So let's come up with a function of theta that has the x squared plus 64 in the numerator and then a constant in the denominator. The only choice we have is the 8. Okay, so which trig function has hypotenuse over adjacent? That's the secant. Alright, so secant theta equals this over 8. We need it to be over 2. Okay, so to make it over 2, we're going to multiply both sides by 4. Alright, and now I've got the 2 on the bottom. So this over 2, alright, what do we have here, is 4 secant theta. Okay, now we also, down there in the bottom, if you notice, we have an x squared. So we need to figure out what that is. Well, here's x. So x squared is 64 tangent square theta. Okay, so now we know what that is in terms of theta. Alright, and then the dx. Alright, so we're ready to substitute in everything we have here. Alright, in the yellow, that's 4 secant theta. Right, in the blue, alright, that's over, that's down in the denominator. So that's over 64 tangent square theta. Right, and then up top the dx, that's up top. Okay, so that's 8 secant squared theta. Alright, d theta, oops, forgot my d theta. Okay, so everything's been substituted in. Let's clean up a little bit. So 8 times 4 is 32. That'll cancel with half of that. Now, secant theta times secant squared is secant cubed theta. Okay, I'm going to pull this 1/2 out. So this up top has combined to this. Okay, that's all we've done so far. Now we're dividing by tangent squared. Okay, that's sine squared over cosine squared. Okay, so that means we're going to flip and multiply by that. We're going to flip it and multiply by cosine squared theta over sine squared theta d theta. Alright, secant cubed is the same thing as 1 over cosine cubed theta times, we got a cosine squared theta over a sine squared theta, d theta. Alright, cosine squared cancels with two of the cosine cubes, and we're left with just a cosine down there on the bottom. Alright, and then we also have a sine squared. Alright, 1 over the cosine is secant. 1 over the sine squared is cosecant squared theta, d theta. Alright, now I'm going to use a Pythagorean identity right here. The cosecant squared theta. If you recall your Pythagorean identities, cosecant squared is 1 plus the cotangent. So I'm going to say that this all is 1/2 the integral of secant theta times 1 plus cotangent theta d theta. Okay, and again that's cosecant is 1 plus cotangent squared. Alright, scroll down a little bit further, we got 1/2 integral. I'm going to distribute secant through here. Alright, so secant theta times 1 is secant theta. Now, cotangent, remember cotangent, we just did it a second ago, is cosine squared over sine squared. Alright, that's what the cotangent is equal to. So when I multiply by the secant, remember secant being 1 over the cosine, I'm going to get a cancellation there. So I get the secant plus, I'm going to write it as cosine theta over sine squared theta d theta. And what this allows me to do is split this up into the integral of secant theta d theta plus the integral of cosine theta over sine squared theta d theta. Alright, so here's where we left off last time. So we got 1/2. Alright, the antiderivative of secant is again the natural log of the absolute value of the secant theta plus the tangent theta. Alright, and then plus, we've done this one before, but just, you know, if you need a refresher, if you let u equal sine theta, then du equals cosine theta d theta. Okay, so you've got a basically an integral of 1 over u squared du. So that's going to end up being minus 1 over u plus c. Alright, and then start back substituting to get us back to our original variable. Alright, so natural log secant theta plus tangent theta plus negative 1 over u is negative 1 over the sine. 1 over the sine is the same thing as cosecant. So instead of writing this as minus plus negative, I'm going to write minus, and then instead of 1 over the sine theta, I'm going to write it as cosecant theta plus c. Okay, Secant theta is hypotenuse over adjacent, so square root of x squared plus 64 over 8. Tangent theta is opposite over adjacent, so that's x over 8. Alright, and then minus cosecant theta. That is the hypotenuse divided by opposite, so over x. And I gotta distribute that. I'm distributing them half through as I go, so I need to make sure I move this over enough to give room for the 1/2. So minus 1/2, and again cosecant is x squared plus 64 over x. Alright, and then we can do just like we did before, alright, because of the 1/2, because of the log and everything kind of combining, we can say this is 1/2 the natural log of just the numerators sum. So x squared plus 64 plus x, right, minus half the log of the denominators. Again, all that's going to be gobbled up by the plus c. Alright, and then we get minus the square root of x squared plus 64 over 2x plus c. Alright, so there's our answer for this one. If you factored out that 1/2 or whatever, that's fine. But or if you didn't distribute the 1/2 back through, that's fine. But this is the overall form of what your answer should look like. Alright, once again we got a sum. Alright, I'm going to pull this 25 out just like we did before in the last problem when we had a number in front of the square. So this is going to be 5 over, I'm going to pull the 25 out, and I'm going to call that 1/25 plus t squared dt. Alright, this will reduce, give me a 1 and a 5. Okay, but I have now I have something plus a variable squared, so it's a tangent substitution. So I'm going to let t equal to 1/5 the tangent theta. Alright, a in this case, the number in front of, or the thing that's being squared is 1/5. Square 1/5, you get 1/25. Okay. Alright, so that means that the tangent theta, if I multiply both sides by 5, is 5t, which is like 5t over 1. Alright, so if I make my right triangle, tangent is opposite over adjacent, so that leaves this to be 1 plus the square root of 1 plus 25 t squared. Now, again, if I look carefully at what I have here, this is again in the denominator. Okay, so I'm going to put this up top, this on the bottom. So I need a trig function that's equal to 1 over the square root of 1 plus 25 t squared. Alright, so what's equal to this divided by this? That's adjacent over hypotenuse, so that's the cosine. Alright, and if that's the cosine, then if I square top and bottom, I get cosine squared is equal to 1 over square this, I just end up with 1 plus 25t squared. Alright, and then to get that 5, I'll multiply both sides by 5. Okay, and now I've got 5 over 1 plus 25t squared, so I've got this to look exactly like this now. Alright, so that's equal to 5 times cosine squared. Alright, now dt, if this is t, 1/5 the tangent, then dt is equal to 1/5 secant squared theta. Alright, now I'm going to temporarily keep these t's. Alright, yellow is 5 cosine squared. dt is 1/5 secant squared theta d theta. Alright, 1/5 cancels with the 5. Secant squared and cosine squared are reciprocals, so this becomes t equal -1, t equal 1 d theta. Alright, now I can integrate this over theta and then switch back using the inverse tangent, or since I have this thing in terms of t, I could switch that over to theta and then have a very quick and easy antiderivative to plug into. So t equals 1, that means 1/5 the tangent equals theta. So to get these new limits of integration, to get this and this, I'm going to make use of this right here. Right, t equals 1, that means 1/5 tangent theta is equal to 1. Alright, so if I multiply by 5, I get tangent theta equals 5. So theta equals the arctangent of 5. Alright, that's the upper limit of integration. Alright, and then the lower limit, just do the same thing except set it equal to -1. So 1/5 the tangent equals -1. That means tangent theta equals -5, so that means theta equals the inverse tangent of -5. Alright, so this integration becomes, the upper limit becomes inverse tangent of 5. The lower limit becomes the inverse tangent of -5, and then d theta. Okay, now this is theta and this is theta. Okay, the boundaries of our integration are now in terms of theta also. So when I take the integral of d theta, I get theta, and then I evaluate from arctangent of 5 down to the arctangent of -5, and then just plugging those in gives me that exact difference, the arctangent of 5 minus the arctangent of -5. Alright, now this will actually simplify, and if you come with me to this slide, I'll explain why. So remember, theta is the arctangent of 5. that means that's the angle that causes the tangent to be 5. And tangent is slope in the unit circle. So starting from the origin going up to another point on the circle, tangent is the slope of that thing, and the arctangent is the angle that causes the slope to be that. Alright, so if the slope is 5, so let's say that this rose 5, ran 1. Alright, so that makes that slope 5. Look at our other number. It's the arctangent of negative 5. So if I reflect this thing over the x-axis, so I get a negative 5, down 5, run 1. Because of that, because of the way that this works, that's a mirror image of where I would hit up here. So that means that this theta is just the opposite of whatever this theta is. If I went up so many units to get here, so many radians, then I just go down that exact same number to get the angle required to make the tangent negative 5. Okay, so what I'm trying to say is the arctangent of negative 5 is equal to negative arctangent of positive 5. Okay, arctangent of negative 5 is the opposite of the arctangent of positive 5. The angle required to get the tangent to be negative 5 is the opposite of the angle required to get that thing a positive 5. Instead of going up to get the slope to be 5 over 1, we go down that exact same amount to get the slope to be negative 5 over 1. Right, that's what this is saying. So it's the opposite direction, and it's the opposite of tangent of 5 over 1. Now going back to this, according to what I just wrote right here, is the opposite of this. So making that substitution, I get tangent, arctangent of 5 minus, and then this in the yellow is the opposite of the arctangent of 5. Okay, this and these two things are identical, and then there's that minus sign that was between them. Alright, and then minus a minus is a plus, so this is the arctangent of 5 plus these two gives me another arctangent of 5. So this simplifies to 2 times the arctangent of 5 as our simplified version of this answer. Alright, and then the last one. One more tangent because it's a sum. So we'll let x equal square root of 64 is 8 tangent theta. Alright, so dx equals 8 secant squared theta. Alright, tangent theta is equal to, divide both sides by 8, is equal to x over 8. Alright, tangent is opposite over adjacent, so that leaves this to be the square root of x squared plus 64. Alright, now I also need to know what x squared is, so x squared equals 8 squared tangent squared theta. Alright, 8 squared is 64. Alright, so I've got the x squared, and then the dx I've got right there. So let's highlight everything. Dx is 8 secant squared. Okay. X squared is 64 tangent squared. Okay. Now, the last thing we need is something with a constant over this radical. So the constant over the radical using my right triangle gives me this. Alright, what function of theta is that? That is adjacent over hypotenuse. Adjacent over hypotenuse is cosine. Alright, and then instead of 8, we'd like to have 72. So I'm going to multiply by 9. Alright, and then 9 times 8, these two things multiply together, they give me a 72. Okay, so now I've got 72 over x squared plus 64, square root of x squared plus 64, that's 9 cosine theta. Alright, so start substituting everything in. Alright, 72 x squared over 64, that's 9 cosine theta. Alright, dx is 8 secant squared theta. And then x squared on the bottom. X squared is 64 tangent squared theta. Alright, 8 will go into 64 8 times. So I'm going to pull that 9/8 out of my integration. Alright, a cosine and a secant, they're reciprocal, so I can multiply one of these cosines and one of these secants. Now I have a secant theta up top, d theta. I got a secant theta up top, and I've got still a tangent squared theta down below. Alright, so hold on to that 9/8 on the outside for now. Secant theta is 1 over the cosine. Tangent theta is sine squared theta over cosine squared theta. So when I divide, I flip and multiply, and I get a cosine squared theta over a sine squared theta. D theta. And once again, I'm going to get that cosine to cancel. I got a 9/8 integral. Up top I just have a cosine. On the bottom I have a sine squared. Alright, and we've seen this integral before. It shows up a lot when we do trig substitution, especially the ones involving tangent. So I got 9/8. I'm going to let, over here, I'm going to let u equal sine. So that means that du equals cosine theta d theta. So there's the cosine and the d theta, so that's du, and then this is u squared on the bottom. So that's going to be 9/8 times the antiderivative of 1 over u squared du, and again we've seen several times now that that's 9/8 times negative 1 over u plus c. Alright, u is the sine, so negative 1 over u, negative 9/8. 1 over sine is cosecant. Alright, and then going back up here, cosecant is hypotenuse divided by opposite. So square root of x squared plus 64 over x. So that's negative 9/8 the square root of x squared plus 64 over x plus c. And then technically we like join these together. Alright, so negative 9 over 8x. Okay, so there's your 3 examples of the tangent.